Okay, so let's kick this off. So my name's Andy Davies. I work for Reactor, the software consultancy based in Finland. We're always looking for new people, so come and talk to me if being a consultant sounds interesting to you. And I'm going to talk about feature toggles. And this talk is made up of a few stories that I've experienced personally and a few ones that you might have seen in the news, which, tells you that something went wrong because no one enters the news for good use of feature toggles. So the good, the bad, and the ugly. So we're going to start with, probably a combination of the bad and the ugly. So who's heard of Knight Capital? Have we got a show of hands? Okay, like 1, 2 people. Good. And that means you know exactly what I'm about to talk about. So Knight Capital were a market trading company in America, one of those high-frequency traders. Apparently they did market making and market growing. I'm not really sure what it means, but I think it means they're responsible for the credit crunch. So I don't like them already. The reason that they're in the news is because they had a slight hiccup one day with their deployments. And on that day in question, they had $365 million worth of assets available to them. That's an important number, so try and remember it. So this is a graph of their share price on the day in question. And you can see there is quite a drop suddenly. This is also a logarithmic scale as well, so this is a really big drop, not just a big drop. And although this graph doesn't show it very well, that drop happened in a 45-minute window. And it all came down to how they develop software and a misuse of feature flags. So they had 2 features in their software. One was called PowerPeg and one is called SMARS. I'm not entirely certain what SMARS stands for, but PowerPeg was an older feature that counted the number of shares against an order. So someone would say, I want an order of 48 million units of whatever, and PowerPeg would split it up in some manner and send them out as smaller orders to the market so they could be fulfilled, and then it would total up how many, and once it hit the complete total, would close the order. Now this was behind a feature flag and had been in their code base for 8 years, and during that 8 years had not been used. Which, things break over time. Code shouldn't break over time, but it does. And they decided that they needed to replace PowerPeg with a new feature called SMARS, which would do the same kind of thing but split the orders in a different manner. Now, as SMARS replaced PowerPeg, they decided to reuse their feature toggle. So we've got some pseudocode-ish of roughly how this worked. So, for instance, an order comes into the system, and if the feature is enabled, we will just enter a loop that says, while we have not fulfilled the entire order, submit a new order for just one item. And the submit new order function does some kind of complex submission and then increments the counter of how many it's been submitted with by 1. And if the feature flag is not enabled, we'll just submit the order but send all at once in one big hit. Now this was the old code, and they replaced it with this at some point. So this was an optimization because they realized that counting things one at a time was bad, so they moved the order current count out of the submit function and into the grand total, like where you can see up here. Now while this works for when the feature flag is off, what happens in this while loop if the feature flag is enabled? Suddenly it's not counting anymore. That current is never going to increase. So you've essentially got an infinite loop up here. Now, as the feature flag was never used, this was not a problem. When they eventually decide to replace it with the new SMARS feature, they delete all of this and just have their complex submission order logic. The count equals the total at the end, and you can see there's no infinite loops available here. The reason this is bad is because they reuse their feature toggle. So, like all good organizations, they have a QA environment, and they test the QA environment with the feature flag switched on for their new SMARS feature, which indicates green. So blue is current release, green is the new release coming in, and we'll see red in a minute. So they test it in QA, and everything works fine. So they do a dark deployment to production. Now you can see here that they've got 8 servers, but only 7 of them have got the dark deploy. That's because their build system or deployment system doesn't report when a deployment fails. And it failed for 1 out of 8 servers, which again is not a huge problem, until they switch on the feature flag. And now 7 of their servers are using the new code, which works fine, and one of them has an infinite loop that is now trying to submit orders to the market as fast as it possibly can. And they're a high-frequency trading company, and the keyword there is high frequency. So it's doing it really fast. And someone notices that they're suddenly submitting a lot of orders that they should not be submitting. And so they do the logical thing, if you're not using feature flags. They roll back to the previous version. Whoops. You've now got 8 machines running as fast as they can, submitting orders as fast as they can for forever. Which is worse. Approximately 8 times worse. And eventually, 5-10 minutes later, someone realizes this is happening and switches off the feature flag, and everything goes back to normal. The trouble is, in the 45 minutes of time that elapsed, they spent $450 million, which is more than the number of dollars they had to start with. Because they had 365 to start with, and now they've spent 450. You'll also notice that I described them at the beginning as they used to be a market trading firm. Because they don't exist anymore. They were bought by a competitor for no money because they didn't have any money. Because they spent it all. So, from this slightly amusing tale, there are multiple problems, but the one I really want to point out is don't reuse feature toggles. Don't reuse a flag. Make a unique flag for each feature you deploy. Because if they had used a separate flag, their deployment could have still failed, and they'd have switched on the new flag. Say you have one called PowerPeg and one called SMARS. You switch on the SMARS one, and you now have 7 servers using the new feature, and the 8th server doesn't know what a SMARS is, hasn't done anything. Importantly, it's not switched on the old feature, which is broken. So, while your deployment wasn't successful, you've not spent all your company's money. And as a follow-on from that, and kind of implied in the name, is you should really name your toggles like specifically to what they are. Because if you just have a thing called like my new feature, you're going to then have my new feature, and no one really knows what those are. My new feature old. You can't just rename them like this. If the flag had a different, like a really specific name, like enable PowerPeg, then they wouldn't have been able to reuse it for the SMARS thing because it would have been enable SMARS, and then they'd have created a new name. It also means that when you're reading a code base, you can figure out what these flags are by just looking at them. We've got 4 examples here of different flag names. The top 2 are pretty good. They're fairly descriptive. And the third one, it's a Jira tag, obviously. It's unique, I hope. But you have to go to Jira to figure out what pay123 is. But at least it's unique. So you could combine that and say pay123-enable PowerPeg. That would be fine. It's unique. You've referred back to the ticket that it's about. And yeah, things are fine. But please don't call it new feature, because then you'll have new feature, new feature, my new feature, newest feature, new feature 2. Yeah, you're not adding any discoverability to your code base by giving things obtuse names. And I know naming is hard, but you should at least know vaguely what feature you're adding. It should kind of have a name. The last point to come out of this particular story is that you should keep your toggle lifespans short. Now, there's many reasons you want to do this, because if you've got a feature toggle that's been in forever and is on forever, why do you have it? There's clearly an off branch that doesn't need to exist. Just delete the toggle and leave the code in. We'll cover this a bit more later. But also, if you've had a feature toggle in and it's been there for 8 years and has not been used in 8 years, the likelihood of it working when you switch it on is quite low, because even if it compiles, your tests probably don't cover it, and you're just asking to spend more money than you have. Also, on this subject, use trunk-based development. Who here uses trunk-based development? Show of hands. Okay, there's 3 people who are doing it right. The rest of you need to start. So with trunk-based development, you just do a tiny commit that just removes the feature flag and deploy that. And it's only a few lines, and if everything breaks, you can just undo the one commit. Trunk-based development is amazing. That should be a separate talk in of itself, because I could rant about that for hours. So yeah, we're going to ignore that bit. But also, if you delete some code, like your feature toggle, and then you need it back, that's what source control history is for. You are all using source control, right? I don't see anyone saying no. So, so yeah, if you need to get your code back, it should be there in history, and if it isn't, you've probably got other problems. So this was an example of a feature toggle that they could switch on and off at will, which puts it somewhere in either activity or periodic. We've got roughly 4 categories of feature toggles. Have compile time flags, and basically the further to the left of this diagram you are, the less flexible. So compile time feature flags, the only time I've really used them was enabling the SQL profiler in a build of a microservice once. And we had that behind a feature flag because it really caused performance problems. And so we only ever put that in if we knew there was a performance problem and we wanted to run that profiler in production. So the only time it went into the code base was if that compiler flag was on. Startup toggles are probably the easiest way to do toggling. You don't need anything to poll services or anything. You can just read a configuration file on startup, switch on and off features. It's not very flexible, like everyone gets the feature or no one gets the feature. Periodic ones, pretty much as it says, it checks the state of the flag in the background constantly, and say every 15 minutes checks and then enables or disables a feature based on that. And then finally we've got activity toggles. This is where, I don't know, a web request comes into your server, and at that point it checks if the toggle is on and either does one thing or the other. Usually when you implement an activity toggle, it's actually implemented as a periodic one in the background, because if you're handling every web request that comes in and then you're calling some kind of feature flag service, you're adding round trip time. And no matter how fast your service is, especially if you're using a third party like, say, LaunchDarkly or something, you've got to round trip their server before you can respond to your request. So there's a speed element to it as well. Now, the use of compile time flags versus startup flags can actually have a huge impact on your speed of development. So my next story concerns another fairly unknown company. I trust some people have heard of HP. In this case, we're going to be talking about their printers. So their printer division has about 400 to 800 developers at the time of writing, and about 10 million lines of code or more. And they averaged about 2 releases a year, which is great speed. And they worked out that an engineer's time, a massive 5% was spent on writing new features. And 95% was not just like filling Jira tickets in, but like merge issues and fixing things that were broken from things they'd done before. And the reason they spent so much time fixing things was because their feedback cycle was 8 weeks. Now, I don't know about you, but I get irritated if the build takes longer than 10 minutes. I can't imagine waiting 6 weeks to find out if my code worked or not. 6 weeks, was for 6 weeks of that was manual integration testing, and the whole thing took 8. Part of this was down to their branching strategy. So essentially they had one branch per printer series, and then they had if-defs throughout the code base. So like, if printer model is being compiled is DeskJet 850, then enable this bit. If printer model is SuperJet 1000, which I might have made up, then enable these other features. Each branch had its own build, and each took 8 weeks. And like, the code itself looked something like this. So you just had can this thing double side print? And you had these kind of if statements scattered throughout the code base. Now, on this diagram, we've got some red marks here. These are where bug fixes are happening. And then the little lines represent, other commits, adding configuration, new features for a new printer series, that kind of thing. Now, bug fixes affect more than one printer, so you have to merge them between your branches, and then you end up with this. And if each merge takes 8 weeks, and you do something, and someone then tries to cherry pick the fix onto their branch, but they also take in some of your configuration, and now that breaks, and 8 weeks later, someone comes up to you and goes, "Hey, the thing you wrote breaks." And you're like, "What thing?" "Oh, the thing you wrote 8 weeks ago." 8 weeks? I can barely remember what I did this morning. And 8 weeks there's a lot of time for other problems to come in and then compound on that. So what they decided to do is switch development methodologies to trunk-based development, because that is the right way to develop software. I have opinions, by the way. They're not necessarily right, but they are. So they switched to trunk-based development. And essentially, each branch still existed, but it was just merged straight into master. So you had small bug fixes coming in, and then you had here's a double-siding branch, and then there's a new printer model. And the way they achieved this was by switching from compile time flags to a startup flag system. So each printer had a config file listing out all of its capabilities, and on startup, the firmware would report what printer model it is to the application, and then it would pick the relevant configuration file based on what printer model it was. This meant you could end up with code something like this. Again, this is made up because HP wouldn't give me their source code, and I very much doubt it was written in C# anyway. So on the printer start, we read some firmware metadata, pass the model into our configs, and then we pick the right config. And the config might have something interesting in it, like, is this a color printer? What features does it have enabled? And by putting this all into configuration files, instead of having if-def scattered throughout the code base, you can just have, as an example, single function, can this printer double-side? And it only is based on what features that printer has, rather than a massive list of if-defs saying, if it's this printer or 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 this printer, but this revision with this extra attachment. And by doing this, not only have they stopped using if definitions, so they've got more flexibility. They only have to have one build that can be tested, because it only has one code path throughout. And the rule that comes out of this is their architecture really matters. I don't want if definitions scattered throughout my code base, because it makes it hard to track. What does this affect? Whereas if you've got it in one place, that one function that just says, can this do double-siding? Is this color? You're making your code clearer to read and trying to isolate what changes based on feature flag status into one place. So don't splatter if statements around your code base if you can avoid it. By doing this, they also went from having around 8 weeks feedback cycle to 2 days, which is quite an improvement. I mean, 2 days is still slow, but then you realize that their feedback also includes spinning up real printers and testing that the firmware actually works on a printer. And by only taking 2 days, you now don't have 8 weeks of other failures in your branch, which causes your failures. So looking again at our flexibility, we can add four usages of toggles to this. The first one on there is permissions, which don't do it. You shouldn't be doing permission systems using a feature toggling system. Yes, essentially it's the same thing, but it's an if statement at the end of the day, so essentially you could implement everything as feature toggles, and yeah, it would get messy. You can do permissions with it, but don't, because it implies that the thing needs to exist for a long time. And if it exists for a long time, it's not a feature toggle. So ignoring that, we have operations toggles. So these are things that you want to switch on and off based on performance, for instance. Say your system is running, but under certain conditions, you might want to gracefully scale back certain things. Like the Amazon homepage. If certain systems under a load, you might not get customized recommendations. You'll just get a static list of products instead. Rather than having an automated system, you could just switch that on and off with a flag. Then you've got experiments or feature flags. So this is where you want to see, if I color the release button green, the buy button green rather than blue, will I have a higher click-through? So you've got a fairly short-lived experiment, and you might only release it to a small subset of users. See how that works, and then you either delete the green version of the button or delete the blue version of the button based on your data. And lastly, we've got the release flags, which is where you want to switch on a feature and progressively roll it out to your business or to your users. This is useful if you think something works, but there might be a performance issue when you hit a certain user threshold. We'll cover this in a while as well. So, ops toggles are on the right-hand side of the scale. They need to be fairly periodic or activity, because if you've got a performance issue, you don't want to have to rebuild your entire application and then redeploy it and then switch on the new deployed version, because that's not very responsive to change and things might have already broken. So as an example, in a previous company, we had a large background process which put a huge amount of load on the database, and under normal circumstances, this runs and it was fine. However, if anything caused the database to slow down for other reasons, we could switch off this background process for a while and no one would notice, and we'd reduce the load on the database so it kept the rest of the system responsive. For added fun, this was a single database and everything came to the same database, relational one. So no offline transactions or things happening off a read replica, everything on the same database. So what we did is we had the toggle service, had a toggle to switch on and off this background process. And then we had a performance monitor which monitored the database, and if the performance went down, would switch off the service for a while. Now, we ended up with the most complicated performance monitor you've ever seen. Not even AI, better than AI, not machine learning. It was actual intelligence. It was the DBA. He would watch it and then switch on and off the performance monitor, or switch on and off the background process. And, his heuristics were pretty good. I don't think we could have trained a net as well as we could train him. But eventually we wanted to put this toggling service to be automatic, because he's got better things to do with his time than switch on and off flags. But if we moved it to being automatic, we'd have to put a lot more effort into it. We'd need to monitor the state of the flag. We don't want it flapping on and off, because while this process can be off for a while, people will eventually notice. Think of like a search index or something. People won't notice if it's a couple of minutes stale. If it starts to be stale all the time, people start noticing. But we never actually got round to doing that, because we replaced the entire thing with an Elasticsearch instance and removed the problem entirely. But if we wanted to improve it, just having a manual switch was a good stepping stone. And it meant that we didn't need to invest in a huge amount of time until we could prioritize replacing it with Elasticsearch. So that's operation toggles. Experiments can sit across a larger area of this graph, because if you're doing microservices, Docker containers, if you want to switch on and off a toggle and you've got 20 container instances running, you can just switch it off for some of them and kill them and restart containers. Basically, the more impact or the more risky your experiment is, the further to the right of this graph you want to be. If it's not very risky, a startup toggle is the easiest way to do it. But if it is risky, like it might cause you to spend $450 million, you probably want to have an activity toggle so you can switch it on and off fast when you realize something is breaking. And finally, release toggles are even further to the left, because it's probably, if you're rolling out a feature slowly to the business, you've probably already tested it to a certain extent and you don't need the activity level of things. Compile time is iffy. I mean, you could essentially have two versions of, say, a container, one with a feature, one without, and you can slowly replace instances with the new version. So it is a valid strategy, it's just not very flexible. as an example of this, another place that I used to work had a system for sending emails. Now, it was in-house IT, had about 500 users, and the desktop software was not allowed to send emails via Exchange directly, but servers were. So someone had written a SOAP XML service, and you'd serialize a mail object into XML, send it to the SOAP service, which then send it to Exchange to send it. Essentially, a lot of pointlessness. There's no added security on this other than it's not using SMTP. Now, this serve service there were many problems with this. The first off was the SOAP service was terrible. And the second problem was that Exchange was worse. Exchange took, on a good case, about 600 milliseconds to send an email, which seems really slow to me, until you realize that for a half-hour period every day, it would take 30 seconds to send a single email. I have no idea why, but on the monitoring graph I could see the half-hour window, and it would slowly move back over the days. So I assume there was some kind of caching thing being cleared, and it took half an hour to repopulate. Maybe. None of us could get to the bottom of it. Unfortunately, the SOAP service didn't really handle this very well, and we left an open TCP connection from the application to the SOAP service while it was trying to send, and then suddenly something takes 30 seconds, and the user of the application gets a giant lump of XML back saying, something went wrong, we don't know whether your email was sent or not. So that wasn't great, and we wanted to replace it. But the SOAP service was also doing email formatting and rewriting sending addresses based on whether you're running in dev or production and that kind of thing. It did a lot of extra stuff that it really should not have been doing. So we implemented feature toggles to replace this slowly, and we used, as we were doing trunk-based development, we used branch by abstraction. So in our case, the first thing we did was take our web service connector and extract an interface for it, so an iEmail connector. And we had two versions. We had one for a web service and one for RabbitMQ. And in our application startup, this is using... What is this using? It's ASP, MVC thing, container, whatever it's called. Their dependency injection. So we query the toggle state on startup, and if the queue is enabled, we use RabbitMQ, and if it's not enabled, we use the standard web service. It's not very flexible. So eventually, we started using a different way of doing this, which was the idea of, I suppose this is a factory of forms, basically a single connector which then does the decision of whether the toggle is enabled and which actual sender to use based on a periodic check of the feature toggle state. And that meant that we could replace we implemented both of these, and then we could do a phased rollout. And after a long time, we implemented all of the things that the SOAP service should be doing as decorators down here. And once we thought it was ready, and we'd tested it ourselves, we wanted to find out how does this actually work? Does it fulfill the business's need? Do they notice that there's a difference in the emails? And the way to do this was to find the user in the system that complained the most about the problem. Like, we had a particular user, and he was a pain in the arse all the time. Like, 90% of tickets raised were by him complaining about something. But it also means he's highly invested in the system. So we said to him, would you like to help test a new way of sending emails? It should reduce all of your errors, and it'll be faster and better, and it'll make your life happier, and you'll make more money. And as he liked making money, he said yes. So we switched on this system just for him. He was the only person in the company that had the new system. And he would use it for a while, and then send us an email going, hey, this is broken, this is broken, this is broken, this is broken. By the way, it is faster. And we go, oh, good, glad it is actually faster. And we'd switch off the toggle if it was like a bad problem. He was like, oh, this formatting's not right, it's fine. But sometimes he'd email back and say, this is really broken. Like, we do weird things with images, and they're now all coming through as red X's. So we'd switch off the toggle, and tweak the system and then re-release it and then switch it back on for him, and then he'd test it again. Once he was happy with it, we switched it on to one of his teammates, who was the second most complaining user in the system, and also his brother. I'm not saying there's a family resemblance, but once they were happy with it, which didn't take too much longer, we then rolled out to his entire team, which was a lot more than 3 people, by the way. This is just representative. And at this point, we found an interesting performance problem. So we had a single queue with emails coming in and a worker pulling the emails off and sending them as fast as it could, which, like I said, normally 600 milliseconds, sometimes 30. And, pardon me, the problem was the system had a mail merge feature, and they could send around 1,000 emails at once, and it didn't queue it up as one email job, it queued up as 1,000. And the problem occurred when a second person sent an email after someone had done a mail merge, and they're on the phone with someone, yeah, I've sent you your contract, it should arrive in a moment. And this is the time when Exchange is sending 30 seconds to send an email, and there's 1,000 emails in the queue, and I'm not good at maths, but that's a long time. And that doesn't look good. So we switched off the flag for everyone again, and figured out what do we do about this. Well, fairly easy, actually. We just switched to having 2 queues. Anything that the mail merge system sent went onto the bulk queue, anything else went onto direct, and the workers would just change to query how to try and pull, say, an email off the direct queue if there was something there, and if there was nothing to do, process bulk emails, because no one cares if 1,000 spam emails takes a longer time to send. And once that was done, we could then actually add more workers. We ended up with competing workers, so workers would try and fight each other and Exchange. I still don't like Exchange. Okay, there's music outside. They didn't have any more performance problems with this. So we rolled it out to another team, and to the whole company. And after a few weeks, we then actually deleted the toggle because it had been successful, so we could delete all of the code from the old system, decommission that whole horrible soap service. If we look at a graph of our rollout, it might look something like this. You can see at the beginning, the toggle flaps on and off a bit, but only for a few users. And over time, we get more and more and more, and then we switched off for a while when we found that performance problem, and then we switched on again and it gets better and better. And then there's a sudden switch off, which is when the toggle no longer exists. And we know that we can delete a toggle when it's being queried 100% of the time and giving the same answer to every query. So the key from this is monitor your toggles. You need to know if they're being used or not. There's 2 main queries that really matter, which is how often is the toggle being queried and what state it's in. So if we look at it like this, we can see there's a ramp-up time on the left, which is the percentage of people querying the toggle. This is as we do a phased rollout of a system. Eventually everyone's on the new version which has a toggle, it's now being queried, and then slowly more and more users have used it. And by the right-hand time there's then a phased rollout as people get onto the newer version again, which no longer doesn't have the toggle. By monitoring these things, we can then also add alerts. If a toggle's not being queried for a while, a week, 2 weeks, whatever your time window is, or if the toggle state hasn't changed in a long time, send an alert, because this now is something a developer can action go. This has not been queried by anyone. Delete it, or this is being queried by everyone, but it's always turning on, and it's been on for 100% of the time for the last 3 weeks. We can clearly delete the off case because we no longer need it. The other point on this, is possibly more important, is the user perception that came from this. So our first guy, the pain in the backside, he felt amazing because he was the first person on the system. He was special. He helped design a new thing which really solved one of his major problems and made his life better. And because he had, these are all salespeople, by the way, so there was a slight amount of competition between them all. And he was first. His team also felt pretty good. They got the system before everyone else. I mean, sure, they didn't have his problems of, trying to work out the new system. But they still got it before everyone else, which meant they could sell things quicker, which made them much happier. And then the rest of the business. As far as they could tell, one day everything was slow and horrible, and the next day everything worked. 100%, no problems. They think IT just released something to everyone at once with no problems. So they think we're amazing, which we obviously are. So all these different people had different views on the system, but it's all been positive. And sure, the first guy knows that we didn't write it successfully at the start, but his positive feelings of being able to really affect the system and, like, agile, we were working really tightly with him to make it work. The only problem with feature toggles is, of course, you're adding to complexity, because you've now got two code paths, and if you've got a lot of toggles, maybe they affect each other, and now you might have, well, exponential number of code paths. The other thing I want to say about complexity is that what doesn't add complexity? I mean, everything is complexity. It's just whether you can hide it or make something better for people. You can't completely remove complexity, but maybe you can make an abstraction which makes it less visible. Toggles can also help reduce complexity. The next story concerns actually the same company that the emailing system came from. And this happened after the emailing system, and I really should have known better. So this is a bad story about me. So we did trunk-based development, as I mentioned, for the most part. We'd had two very, very large projects, this internal 1 and internal 2 feature. These are, we're talking like a year or so long branches. We also had an outsourced third project, and we're not sure if they knew how to use Git before they started the project. But at the end of the project, we received one commit, which didn't compile, and nothing else. Doesn't really need to be on here, it's just amusing. So we had these two very large internal feature branches, which definitely affected each other. And eventually, the second one was ready for release. It had been completed, and there was a yes, definitely, we want that to be released. So we merged it into master, and we released it to QA, and we rebased the internal 1 feature onto master. Can you guess what happened next? Business, actually, we don't want that one to go out yet. We'd much rather the other internal feature go out, but not internal 2. I didn't know what the Git ref log was at this point in time, and I really, really wish I had, because undoing a rebase that is a multi-year project is not fun. In fact, we restored from the backup the previous day and cloned that and then worked out what the differences were. It was not fun. We did this several times, by the way, because we're really good at learning. If we'd just used feature toggles and had been merging all this stuff into master, we wouldn't have had all of the conflicts from when, 2 people changed the same database object differently at the same time. And we could have switched on and off these individual features, as big as they were, easily. And like I said, this was the same company where we'd done that successful emailing rollout, but for some reason, time pressures, deadlines, something, we just didn't think about it. We should have known better. So while feature toggles can introduce complexity, they could also save you from having to undo a multi-year rebase. I never want to do again. This is one of the many reasons that I advocate for trunk-based development, because if you're doing trunk-based development, you don't have a multi-year long branch, which is out of date. Or you might do if it's orange and at the bottom, but we can ignore that. Lastly, one of the pieces of feedback I get on the feature toggling is that it makes testing harder. And my answer to that is always, does it? Are you sure? Have you really thought about this? Because you've got your first version of your code, your giant test file that covers, say, 1 page on your website, or 1 component. And you decide to add a feature flag for something. So you copy and paste your tests, which I'll let you do. You can copy and paste them. And one file is for toggle off, and one file is for toggle on. And now you keep both of these test files, because you need to test both on and off states. You run your experiment, and then when your experiment's finished, either it was a success or it was a failure, at which point you either delete the old blue code in this case, or delete the green code. And now you've gone back to having one test file. And your complexity kind of disappeared. The same happens for manual testing as well. You have your 2 test scripts for how you manually test your website. When the toggle is on, I follow this script. When the toggle is off, I follow this script. Right, we're keeping the toggle. I can throw away that script. So you have briefly increased the complexity, but it disappeared fairly shortly afterwards. So to give a quick recap, these are my 5 rules of feature toggles, which I break on a fairly regular basis, except for number 1. I will never break that rule. I don't think. I will never break that rule. Maybe my team might, but they know I'll shout at them if they do. So, yeah, please don't reuse feature toggles, because you will accidentally spend far more money than you possibly can have at the time. Name them well so that they're descriptive. Keep the lifespan short so that you don't accidentally keep code for 8 years which is not used. Your architecture matters. No one wants the same if statement scattered throughout the code base. Put it in one place so it can be reasoned about. And monitor them so you know when to delete them. And 6, use trunk-based development. Maybe that should be number 1. Or 0, actually. Definitely 0. Because, who counts from 1? So, I've got some links here. There's some more in-depth analysis of the Nightmare. Genius naming. And the second link covers HP's DevOps transformation, of which part of it covers that feature toggling. So with that said, I think I've got a few minutes. So what questions do you have? Not that I can see any of you. No, I don't think I can see any hands. Shout if you're trying to say something. Nope. So in which case, I hope you enjoy the rest of the conference. If you've got any questions, come and find me. I'm a chatterbox, so I will talk about anything for forever. Thank you very much.